So here we are, example number 6, a sum and sigma notation. This is the last example you have for chapter 10. So notice we have some sigma notation here. We do have your little sigma. This is your Greek letter sigma, and you have your starting value on the bottom. Remember, this is your start. Okay, this is your starting value. The number up top, this is your final value, or number of terms, I should say, because these are your end values. These are your starting term and your final term. So we're going to go from 1 to 12, and then we're going to have to plug these in for your n of your function. So we need to start writing all these out. You're going to start with a 3 times 2, and for n, you're going to plug in n, or a 1 minus 1. And then we have to start adding all of our other functions through 12. So we're going to have a 3 times a 2 to the power of 2 minus 1, plus 3 times 2 to the power of 3 minus 1, plus 3 times 2 to the power of 4 minus 1. You might want to pause it here for a moment. I'm going to write out the rest of them. So here you have them all written out, finally. Notice that the value that actually changes each time is just your number that is up here. Whoops, that's a little too large. Is this number up here? Okay, 1, 2, 3, 4, and it goes down all the way through 12 because that's the number that's on top. And then what you're going to have to do is you're going to have to evaluate each of these terms. There's 12 of them. Yes, that's a lot, but some of you maybe will do some of this in your head. So it is a little bit of writing, but I have faith in all of you. So that means 3 times 2 to the 1 minus 1, well, 1 minus 1 is just a 0, so 2 to the 0 is a 1, so you really have a 3, plus, you have 2 minus 1 is a 1, so 2 to the first is a 2, 3 times 2 is a 6, plus, you're going to have a 2 squared, which is 4, times 3, which is 12, plus 2 to the third is 8 times 4, or sorry, 2 to the third is 8 times 3 is 24. And then you might start noticing a pattern going along through here. Each of your values keeps getting bigger just by 2. And the reason that is because look at your r value. Isn't your r value, doesn't that mean right here if r is equal to 2, doesn't that mean that each number in your sequence keeps getting bigger by 2? So I'm just going to keep multiplying everything by 2. So here's our 5th term. Here's our 6th term. That's what you get by putting a 6 in here. And then you have a 192. There's your 7th term. We have a 384. And we keep adding. Sorry, you don't keep adding, you keep multiplying by 2. So we're going to take 384 times 2 gives us a 768. Those are your 9th term. We multiply that by 2, and that's going to give you a 1536. So if you notice your pattern, you don't have to keep plugging this into your calculator every single time. So there's your 10th term. So then that means our 11th term is going to be 3072 plus, you should get a 6144. There is your 12th term. So we need to combine and add all of these. A total of 12,285. And that is your solution for 6A. So it looks a lot worse than what it is, because if you notice, and this may help you to write out everything we have up here in purple, just so you can see what your numbers are doing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then if you notice the pattern after a few numbers, which you should, because you should have a ratio, then that can make your answers, finding these numbers, easier, because you don't have to keep plugging this entire equation into your calculator. So that's for A. So let's look at B here. Similar idea. You know, we have where you're beginning with the 4 and where you're ending with the 12. We do have some fractions, which is okay. So we're going to start with a 1/4 times 3 to the k, where we're going to start with a 4 minus 1, plus, then we're going to say 1/4 times 3 to the 5 minus 1, plus 1/4 times 3 to the 6 minus 1, plus 1/4 times 3 to the 7 minus 1. And we're going to continue this on until we get all the way to a 12. So feel free to pause if you like, or if you would like to just hear me keep talking about all the wonderful things that and places that math can take you, because man, I tell you what, if I didn't know my math, I probably wouldn't be a teacher today. I'm just saying. 11 minus 1 plus 1/4 times 3 times 12 minus 1. So what's going to happen is you're going to go through and you're going to find out what all of these values are. So you're going to have a 3 to the third, because 4 minus 1 is a 3. 3 to the third is 27, so you get a 27 over 4. Because 27 times 1/4, that's a 27 over 1. Plus, you put a 5 in here. 3 to the fourth is 81, so you get 81 over 4. Plus, we're going to get 3 to the fifth, which is 243 over 4. That's your third term. And if you notice, the denominators keep staying the same, but your numerators are going to keep getting bigger by your ratio, which is a 3. So if r is equal to 3, you just take 27 times 3, gives you 81. 81 times 3 gives you 243. So go ahead and continue filling these out. You should have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 fractions here. So we got over 4, and your numbers are going to start getting a little bit bigger. So there's 6, there's 7, 8, and 9. So we need to just keep multiplying everything by 4. So if we take 243, times 3, 243 times 3, and that gives us a large number. Oh my. You guys are going to start getting scared here probably. 729. So you have 729 here. If you multiply that by 3, that gives you 2187 times 3 again, 6561, and then multiply again by 3. Oh boy, 19,683 times 3 again, 59,049 times 3 again, 177,147. Now if you add up all these fractions, but the fractions, yeah, that's right, they are fractions. So if you add all these together, you should get a final total of 66,000, I'm going to put it in decimals here, 426.75. So there is your total sum by using your sum notation. And I hope that you enjoyed all of these lovely notes that we got going on here. And we are now officially done with Chapter 10. 'Cause I'm happy.